In this lesson, I will introduce you about mold design. Okay, this is the outline of this lesson. You would like to know the advantage of ZW3D mold. The first is the integrate healing module. Okay, in ZW3D we have the healing functions to help you to repair the modeling. Second one is parameter modeling and direct-guided tools to help you to do the mold design. And the third one is optional mold design method. We have different functions to do the parting line, parting face. Okay. And next we have the flexible parting tools. And the fifth point is we have the standard mold base and parting part library. We support the normal suppliers, and you can also customize your own library for mold base. And in ZW3D mold, we also integrated the electric tools. Okay, what you will learn in this lesson. The first one is the method of mold design, and we have two methods to do that. The first one is non-project manager, and another one is project manager. The second point is you need to know you can start the mold design process in ZW3D. Okay, the first step is to prepare the model. Okay, you need to align, healing, draft and thickness checking. Okay, the step 2 is parting. And step 3 is insert mold base and standard parts. And the third point is to do correct the 2D draft. And last one is about correcting the electric. Okay, let's go to the sample 1. This is the mold design method 1, no project manager. Okay, without a project manager, so you need to do everything by yourself. So from 3D modules, you need to prepare the modules and parting and extract the shape to part. And then you need to correct assembly construct. Next, you need to do the mold details. And last, to export 2D shapes. For different parts, you need to use different functions of ZW3D. Okay, the first one, if you want to open the 3D modules, you need to use the translator. Okay, ZW3D can import files from SolidWorks, Pro-E, Korea, CATIA, NX, Sony Edge, Inventor. Okay, and also some other 3D files. And when checking module quantity, you need to use the healing functions to heal the geometry. And when you check the mold structure, you need to use the direct edit to change the module. At last, you need to adjust the position of the part. For mold design process 2, okay, for parting, you need to slide to core and cavity. Okay, you can show the picture, and then touch the inner hole. Here you can find the yellow face, and then correct the parting face and slide it to core and cavity. I will show you the details after the PowerPoint. Okay, and I would like to know the whole process before the real case. And step 2.1 is to slide to core and cavity. We have two functions to do that. Okay, the method 1 is to by parting line. You can correct the parting line and trim by parting line. The method 2 is you can do the corner region deflation and then slide it by the color. The step 2.2 is to correct the inner patch. ZW3D have the automatic functions, okay, smart functions to correct the color, the inner, and we can also support the functions to correct the cutting face. Okay, you can also the step 2.3 is correct the parting face. You can find this is the smart functions to correct the parting face. But sometimes if you want to use to correct some menu, to correct some parting surface menu, you can use the basic functions of ZW3D. And last one is trim to core and cavity. This one is very easy. And step 2, you need to add the mold base and standard parts in mold design. Okay, so for standard part, you can also ZW3D support the different supplier from okay, let's say the details, some details. Okay, you can find the supplier. We support DME, Fatbar, Haskell, LKM. Okay, and you can insert the standard part in the mold. And last, if you want, you need to modify the standard part, and you can also build the materials. Okay, to export the boom table. Okay, this is to correct the 2D shade. So this is the process. Let's go to the first case. Okay, this is the first case. In this case, you need to know how to heal the heal functions, and we have two methods for supplier, and you can know how to correct insert and slide and mold base and mold standard library. Okay, let's go to the software. So let's go to open the file. Okay, you can find this is an IGS file. So open the IGS file, and you can use country and A to show the part. This part is not in the original point. Okay, so you can right click and set original, so you can rotate it more easy. In this part, you can find there are many open face. So you can use healing to check. Show me the open edge. You can find they have 61 open edge. So I need to heal this part. You can find they have many heal functions here. So we can use this one. Fill gap is very normal. So you can fill the gap and press OK. Fill the gap, and you can find ZW3D will select the boundary automatically and press OK. Okay, the same. Press OK. And you can also use the normal functions to heal this part. Okay, so we can use the freeform. Press OK. And for this area, you can also use curve mesh. Okay, so we can choose the U and V UV curve. Okay. So in this area, you can find this service, or you can use the trim to curve. So you can select the curves. Press OK. Oh, select the face to keep. Okay, I want to keep the inter. So press OK. So for this area, okay, you can also use the powerful functions fill gap. So after that, okay, you can find you can use here open, and they still have a 27 open edge, so zoom to. So you can find this is the open face. You can find if I change them to wireframe, you can find the more clear. So with this one, you can use swirl. Okay, you can select the wall and press OK. So then you can find they still have a 15 open edge. So zoom to another one. So with this one, you can find there are two very close, small gaps here. So you can use close gaps. Okay, choose these two lines and press OK. Close open edge. So then you can find, okay, it's closed. So and zoom to next one. Okay, for next one, you can find this is the still this is a surface you still need to trim the surface. So I can trim its face with curves. So I can use Shift or right click to choose quick pick. Okay, and side to cape and press OK. So you can find they still have some blue lines. Okay, I can use the pure swirl, press OK. So after that, let's show me the open edge. You can find still have a 4 open edge. So zoom to. Okay, here. This is the open edge. So with this one, you can also use fill gap, but I want to use another way to do that. Okay, so I can use the extend functions. Extend the face, and then slide, trim this curve, trim this face by this curve, and the face to clip, and press OK. Okay. This is still have a one open edge, so I can use hue, swirl, shape, press OK. So now you can find it. Okay, I healed this part, but you can find here in this one they have a two solid. Actually, one of another one is not necessary. Okay, so I can use the combine functions. Choose this one and remove this one. Press OK. So now you can find this is the real part. So next, I would like to correct a mode for this part. So you can find here, this is the whole process for mode design. So the first example is I need to align the part because this part is not in the original point. Okay, so I want to put them in the original point. So if you use the basic functions, it's difficult to do that, but ZW3D supports align functions to do that very easy. So just select the shape and parting direction. So I can right click, choose the surface, and the side location is part center, and press OK. So you can find the part will go to the original point automatically. Okay, so press OK. So then next step, I need to do the draft thickness. Draft analyze. So I choose draft analyze and select the direction. So it's CSS, and the angle is 0. So I can check. They have you can find they have some green surface. It means this surface is undercut. Okay. So I need to, maybe I can give one. You can find the blue surface is need draft. So I need to use draft functions to draft this surface. So I press OK. So next I can use the draft functions. I can also use the direct edit functions to do that. Okay. So I can right click and draft the angle. One, two. Okay. And press OK. And you can also choose the draft functions. And then you can select an edge. Edge. And press OK. So now, next, you can still find I have some green surface here. So I can also use the draft functions. Press OK. So now, okay, I finished modifying the part and already, okay, still have a two surface here. So draft, select an edge, and press OK. So now I finished the draft analyze. So next, I need to use the next. You can use the syncness. The syncness functions in this version is not very powerful, but it still can have to do some basic analyze. Okay, so start analyze. Is a little slower. But normally, for the simple part, actually is no need to do the syncness analyze. I show this function is just on you to low. We can do the basic syncness analyze. Okay, after finish, you can change the value here, the maximum. Okay, normally if you can change to 5, so you can find the different color, show the different hue, the different thickness. So you can find this show the green is show the upper, and the red is lower. So you can change, and you can say the different color. And we can find some in this area is the thickness is over than 5 because it have some lip here. Okay, so this is the synchronous analyze. So after finish the synchronous analyze, so you need to do the shrink. Okay, so I can shrink to give the value and press OK. So you can find it's change it's scaled a little big. Okay, so undo, redo. So you can say it's change a little bigger. Okay, so next was that after I give the shrink, next I need to film it to core and cavity. So this is next I want to show you how to touching this give this part. Okay, so the first I would like to show you the region. You can use the region functions to slide it to core and cavity. Okay, so I use region and calculate, select the CSS and press OK. So you can find in the surface was marked with 3 colors. Okay, so the brown and blue and light blue. Okay, for light blue, I would like to change it to cavity. Okay, still have 2 vertical surface here. For the vertical surface, I would like to put them in core. Set them to core. So now all of the surface was marked as core and cavity. Okay, so I press OK. So then you can find next I need to correct a patch for the inner. Okay, you can find they have they have 2 holes and they have 3 holes. 1, 2, 3 here. Okay, but when you check the corner, you can find this area in the corner was not correct. Okay, actually I need to put this corner. This surface must be put in core. So I can run this command again and choose the surface. Okay, this surface must be the core. Select the surface, set the core. Okay, same on this one. And let's put this hole. Set them to core. And press OK. So next, okay, we need to use the patch functions to correct the surface. So you can find for the spline, you just need to select the edge. It will correct the patch automatically. That's okay. For the inner, this one also the same. And you can find they have 2 options: cavity left side or core right side. So it means I can choose correct the surface in 2 ways. Okay, so for the cavity way, for the core way. In order to get a good surface, okay, for the here I need to choose the cavity because in this situation the surface is smooth. Okay, press OK. So after correct the patch, next I need to slide to core and cavity. So I just run slide and choose the shape. and press OK. So you can find totally two new corrected region shape. Press OK. So you can find now it's slided to core and cavity. So I can choose use direct edit. Okay. Change to shape. Change to shape. Okay, blank one. So you can find the part was trimmed to two surface. Okay, and swap. Okay, I'm blank wall. So this is the core. This is actually this is the surface for cavity. This is the surface for core. So next, okay, let's see what I need to do. After I split it to core and cavity, next, okay, this is another functions to correct the parting line. ZW3D also can split it by parting line. So I already trimmed it to core and cavity. So next I need to correct the parting face. So for the first one is to correct the parting face from parting line. You can find I just split it into core and cavity and it corrects the parting line automatically. You can find the green lines. So you can find this is the parting line. Okay. I'm blank wall. So correct the parting face. You can find it correct the parting face automatically. And if you have some, okay, you can find the following functions still to correct the parting face. Okay. So normally for the first one is enough. So press OK. So next, after correct the parting face, I need to correct the workpiece. So choose that, and you can find it correct the workpiece, and I need to change the value. Okay, press OK. Oh, it's not as big as the part. So I can redefine. And press OK. So the last operation is to trim the core and cavity. So choose the workpiece, and for parting, you need to right click and pick all. Because the parting face not only in the boundary, just in the also the parting face. So you need to pick all and press OK. So now you can find it's trimmed to core and cavity right now. So I can blankly find this is the core. And change. This is the cavity. For the cavity, you can find actually for this area is you can find. I just make a mistake. This is must be okay. Let's change to another part. You find I want to make this two area. Actually, I need to put them in the cavity because you need to correct the insert. So I need to modify the part. So I can go back to the oh, yeah, okay, not close. So for this one, I need to do it again. So region, select the service. Let's hold the same. I need to set them as a captive. The boundary surface must be the core. Okay, that's okay. So then the next is I need to add it to edges and go. So I choose core right. You can find if you choose the different edge, the quality of the survey is not good. Okay, so I can use the freeform functions to do that, to collect the FEM functions. Okay, so next hole, press OK. Reverse the direction. Slide it to core and cavity, correct the parting phase, and correct the octaves, and trim it to core and cavity. Okay, so let's check again. Blank. Okay, you can find. Okay, this is the part and swap. Oh, still wrong. Okay, so do it again. The boundary surface must be set as a cavity. So, jam to core and cavity. Correct parting face. Last region is to pick all. Okay. Actually, I need to correct the inset. I would like to correct the inset in the cavity, but I think I must make it in the core. Blank the core. So let's say the cavity. So next, after we correct the core and cavity, So next we need to correct export it to corner cavity. So we can use the assembly functions to geometry to part. Okay, so this is the cavity geometry to part. This is the core. Okay, so let's extrude. You can find this is the cavity and this is the core. Okay, so next I would like to correct inset. Okay, you can find this for this area. Okay, you must correct slide. Okay, so I can insert a sketch here, and then I can use the reference functions. Join the line. Extrude. I want to keep the correct the part. Reference the line and trim the profile. Next, I need to export this part to assembly. Slider. So you can find that this is a slider part. Okay, for this slider part, I need to reference the I can insert the slide. Okay, correct the slide. For the slide part, I can insert the cavity and I can use the merge. After merge, I can use the combine functions. This one and the slide. So you can find this is the slide. So I can add a reference. Use the extrude and to correct the slide. So then for the cavity, okay, I can do the same. Okay, insert the slide. So I can use the combine functions and use remove. Oh, merge in the slide first. I can merge. Remove. So you can find this is the to correct the this is the core. This is the cavity and the slide. I can go back to the total assembly. With this one, with this total assembly, I can insert slide. Okay, you can find. Okay, this is the slide. How to correct the slide? Okay, I can. Okay, go back to the slide. I change the service attribute. Okay, so this is the slide. On another side, you can do the same. Okay, to make it the slide. So next, I will show you how to correct the insert. For the insert part, okay, I would like to correct. Okay, blank. I would like to create an insert for the core. Okay, so I can insert and then I can use reference geometry. And then I need to create a sketch. And drawing a rectangle. With the rectangle, I can choose another way to use the corner. Right click to central of the corner. Press OK. Okay, and in order to make this inset, you can change the value. Press OK. So then I can use the extrude functions to extrude the sketch to side. So you can find, okay, this is the inset. Okay, for the inset, you can also make a field. Smaller. And add a holder. You can, okay, you don't need to correct the sketch for the, okay, you can use the extrude functions to correct the lip. Okay, so I select the edge and select the direction to x-axis one side. Use add, and I can give a thickness. Press OK. So then I give the field so this is the inset. So after that I need to change the color to, so after I correct the inset, so I can go back to the assembly. So let's say in the core. So for the core, I need to, okay, insert the insert. So then I need to merge and use a combine remove. So you can find it. Okay, this is the core, and go back to the totally assembly. Okay, show. So you can find. Okay, this is the core and cavity and slide and insert. Okay, make it much better. So you can show that and make offset and change to shape this attribute. So after I finish the core and cavity, insert and slide, next I would like to correct mode base. Okay, so you can find ZW3D support the mode base. Different slider. So I would like to choose a standard, and you can find it. This is a picture to show you the structure of the mode base. Okay, so you can find for this one, I would like to choose SG, and you can find they have different classes. So I can choose class C, and the thickness of this A is 18, and C, it doesn't matter. So I need to choose the size of the mode base. So I need to calculate the loans is 210, and this size is 310. Okay, so I can choose the size. Forty is okay. And with this one, I choose the size of A and B and press OK. So you can find ZW3D will insert the mode base automatically, but you can find this mode base still a little small, so I need to change it much bigger. So I can use the mode base functions to mode base modify to select the bigger one, 45. update field again. No finish 100. Waiting field. Okay. So you can find I insert the mode base. So now this size is okay. So next I would like to maybe correct the block for the A block and B plan. Okay, so I can use the or and go to this one, and I can use the reference functions, reference as service. Snap right click and pick from list. So and press OK. Then show target, and I can use the extrude, select the surface. One side to cut. So I cut the hole for the cavity. Okay, so then right side, and for the main B, do the same. Okay, reference the surface. Right click, pick from the core. Okay, face from core, and press OK. Then show me the target, and I would like to extrude. To cut. Okay, get the box. For this one, you need to, after you reference, you need to delete a loop inside. Okay, delete the loop inner. Press OK, and then extrude to cut. Extrude, choose the face. Okay, this is the box. Cut the box for the cavity. So then excite to the totally old design, and you can find they have okay, after you insert correct the mode base, next you need to insert the scenario part. Okay, so you can insert the scenario part, and you need to insert the locate ring, and select the face and select the position. The position is between the points. Again, for more, insert the location. Locate ring face, insert point between and OK. Okay, so after you insert the locate ring, okay, you need to correct the pocket for the ring. So the same, select the tools and select the entity and press OK. So you can find it. You can blank the this is to insert the located ring. Blank and next, if you want to correct the electric pin, okay, so you can also use the functions here. But for how to insert the standard part, I will it is in the advanced training for next time. So this one, in this training, I hope you can know how to correct how to slide it to core and cavity, okay, and slide or insert. So let's have a 10 minutes rest, okay? Let's go come back at line 15. So this is the case to correct the hill functions and okay, two methods to slide. Okay, I will introduce another method to slide later and correct insert and slide and move base and move standard parts. So let's go to the sample 2. The second mode design method is project manager. With this one, for example, you can find that this is only one part, but if for the mode, you need to correct 4. Okay, so you need to the process is import the 3D model and modeling prepare and correct the project and parting and mode details design and 2D set. Okay, so let's go to the details. The first step is to correct the project. So you need to, when you correct the project, you need to choose multi-cavity. And then you select, give the project name and string. And then the step 2, you need to lay out the one part to different position. And then slide and correct the combine and correct the parting face. And the following is the same. Okay, trim it to core and cavity and correct the mold base and the center part. In this case, I would like you to know how to correct the project and how to correct the multi-cavity layout and the parting combine and the mold base and the mold standard library. Okay, so let's go back to the software. Okay, so I correct okay, I show you the example first. Okay, this is the part. Okay, with this part, I would like to correct a multi-cavity mold with this part. Okay, so I close it. So I correct a new part, and within the mold menu you can find you can import the part or correct the project. So I correct the project and select multi-cavity and press OK. So the name is my project and shrink and then press OK. So next I need to layout the file. So I choose the file and the data name and okay, define the layout. I can choose two spaces 250. So you can find it. This is the true datum, and you can change it to different style. Okay, X, Y. Okay, so I can choose X and press OK. Then choose the file, the part, and datum to 1, 2, 3, 4, and press OK. So you can find I insert 4 parts in this mode. So next the same. Okay, so you can do the draft analyze or synchronous analyze. The oxygen of the same. So for this part, I would like to tell you how to do the party line. Okay, so I can choose the party line, and with another method. With the party line, if I know the party line exactly, so I can choose it by the correct by lines. Okay, add party lines by lines. So I can choose the lines. For some parts, if it is difficult to use the region, so you can use the party line to correct the party lines. Party line functions to correct the party lines. So and press OK. So you can find I correct the party line. After correct party line, I need to correct split it to with party line. So you can find this one by party lines. I pick all party lines and press OK. So you can find it was changed to core and cavity. So blank core and cavity. Okay, and blank wall. So then next you need to correct the parting phase. So with the parting phase, you can automatically to use the first one to correct the parting phase and press OK. And you can also add a patch here. And for this area, you can find. Actually, I don't want it it's too long, so I can use the last one to correct the parting phase transition by boundary curve. Okay, so this one I need to join a line first. This point along distance. So then I choose the face 1, 2, 3, and then select the curve, and end plan. Right click to insert a datum. And direction is Z-axis. So I can also set the draft angle. So set 5, press OK. So you can find it will be okay, correct. It will change the parting surface like that. Okay, so after I correct the parting face, I need to combine. Okay, so use the combine and choose 1, 2, 3, 4. Make them with this 4 as one part. Okay, so then after that, I need to change the parting face. So I can use the trim to face. Select these two parting face to this form, another side. Okay, after I trimmed the parting face. So then I would like to make this 4 parting face as one parting face. So I can use the hue functions for these 4 main parting face. Okay, so now next I would like to correct an workpiece. Okay, the same. I change name to change the value and press OK. So then trim, select the plant and pick all parting face and press OK. So you can find correct core and cavity successful and press OK. So you can find this is the core and cavity. So I can blank. This is the core and swap. So after that, you can find ZW3D with this component. ZW3D export the core and cavity automatically. Okay, so and when you insert the mobase, okay, check the size again. 400. 140. Okay, insert select the size. Press OK. And all of the following operations are the same. Okay, so you can find it. And the difference is for the project manager. You can find this is the assembly tree. You can easily to change the visibility. Okay, so I want to hide the fit half, the move half, the eject system, the guide, and the, okay, I don't want to show the eject system. And you can find it's disappeared blanked. And the guide, I don't want to show the guide. I don't want to show the eject pin and the cooling and some others. So this is a very good way to control all of the parts with the manager. And this is the advantage of the mode design with the project manager. So, and for the homework, okay, I hope you can try to do with the mode exercise. This one. You can try to make this one. Okay, this one is also the same process. And we have a PDF file to help you, okay, to give you the result. Okay, you can, I hope you can do this one for, do this one on your side. And you can also, from the materials, you can also find a video in the reference materials of non-project mode design. Okay, this is a video. In this video, you can find the totally process. Okay, to correct the insert the locate ring and the standard parts. Okay, and last, I would like to show you the electric module in ZW3D. Okay, so with the electric module, I need to go to the core. Okay, with this core, if you want to correct electric for this slot, so you can choose electric functions and select the direction. The direction is CSS, and select the face. Select face. boundary face. Okay, then press OK. So you can find it. This is the electric, and you can need to add the electric to a blank. Choose the top face. Choose the shape, and then the data, and you can change the size. And then you can find this is the mark. I want to make a mark, so you can find this is the mark, or have a different settings to mark the electric, and press OK. So you can find this is the electric. With the electric, you can correct the sparking joint. Okay, so you just need to select the oak piece and select the electric and press OK. So you can find ZW3D will correct the 2D shape automatically. Okay, it marks the position of the electric, and this is the different views of the electric. Okay, let's go back to the mode. With this mode, ZW3D also have the bone functions. Let's see why it's empty. This is the core and cavity. And this is the totally assembly. Okay, let's use the core and cavity for reference. So with this one, you can find after you press the bomb button, you can find this is the functions to this is the list to show the bomb. So you can set the columns, and you can add the index or another in the list. And then the smart functions is you can get the stock size. Okay, you can choose the stock edit and choose the plan and shape and press OK. So you can find it will get the size of the cavity automatically. Okay, and you can work for the core also the same. Stock edit. Stock edit. Choose the plan. select the core and press OK. So you can find this is the size of the core. So this information is very important for mold design. After you finish the mold design, you need to get the size of the stock. Okay, so you can use these functions to get the size automatically. And you can also export the BOM to Excel. And you can find this is the size for cavity, and this is size for core. Okay, for the details, I hope you can reference this video. Okay, I was going to finish this lesson, and if you have any questions, please send an email to me. Okay, thank you very much.